Okay guys, now it's time for case number 1. Race condition, stealing money from a bank. What I'm going to present to you in this case is how to hack the web application with multithreading. Multithreading is very much related to race conditions. In other words, via multi-threaded attack, we can trigger a race condition. And via race condition, we can launch some really powerful attacks. For example, stealing money from a bank. And this is exactly what I'm going to show you here in this case. Of course, I'm not going to hack a real bank. This is the training, and whatever I'm presenting here is for educational purposes only. But to show you how it works and to show you the power of race condition exploitation, I need to have a demo, and I have one. And my demo is located at training.local/bank in my testing environment. So let me go there right now and let me show you how this attack works step by step. Okay, here is my demo. What I can do in this demo is I can transfer money from one account to another account. To be more precise, I can transfer money from Michael's account to James' account. And the current balance is $1,000, so I cannot transfer more than $1,000, right? And if I try to do it, and for example, if I try to transfer $1,001, which is more than 1,000, then I will see a message failure. You don't have $1,001. Well, this is very much expected. And if I was able to do it, then there would be a disaster in the system, right? So this is how it works. This is how my demo looks like. Okay, what I'm going to do right now is I'm going to move smoothly to the attack that I'm going to actually present here, and the attack is race condition stealing money from a bank. So right now you can see that I cannot transfer more money than I have. But what you will see in the upcoming minutes of this video is that actually I can withdraw more money than I have via race condition exploitation, and it's gonna be really great, really beautiful, and it's gonna be an eye-opener for many people that we can do something like this via race condition exploitation. Okay, so yeah, let's do it. Let me show you how it works. So now I'm gonna present to you how this attack works, how to trigger race condition, and how to steal money from a bank. But we also need some technical explanation behind this attack. So once this attack is presented to you, once you see the power of this attack, then I will jump to the whiteboard and I will try to explain to you why it actually works, okay? So first I will present you that indeed it works and how to make it work. And later on, I will explain you some technical details behind this attack so that you can really understand, why it works. Great. So let's do it. Let me present this attack to you. As I told you at the very beginning, we are talking here about multi-threaded attack. So multi-threading is a kind of prerequisite or starting point for this attack. So we need a kind of a tool that supports multi-threading. I could use Burp Suite Pro, which is not a free tool. You need to pay for this. But, I just want you to be able to do all the attacks that I'm presenting here with free tools. So I'm going to use OWASP Zap instead of Burp Suite Pro in my testing environment in order to show you how it works. First, let me open OWASP Zap. And what I have to do more right now, the OWASP Zap is up and running, is I need to tell my browser that now the traffic sent out from my browser should be actually sent to OWASP Zap, okay? So I need to tell my browser about this. So yeah, now everything is, let's say, configured properly. OWASP-ZAP is up and running, and my browser knows that the traffic going out from the browser should be sent to OWASP-ZAP, because in a couple of minutes, I'm gonna use OWASP-ZAP and multithreading out there to launch my attack, okay? I hope that you are following me till this point. Great. So now I'm about to send a money transfer request. And what you can see here below is amount $10. So yeah, let's send $10 from one account to another account, and let's incorporate this request related with money transfer into multi-threaded attack scenario, okay? So this is exactly what I'm going to do right now. So first I need to turn on the interceptor in OWASP-ZAP. Now it is turned on, and I'm going to click send money, okay? Let me right now go to OWASP-ZAP. And what you can see is that indeed the request has been intercepted, and this request is responsible for sending $10 from one account to another account, right? And I told you that the crucial part here, the starting point actually of the attack, is multi-threading. So I'm going to take this request and I'm going to incorporate this request in multi-threaded attack scenario. And the question is how to do it in OWASP-ZAP. You can do something like this. You can click right on this request. You can click fuzz. And well, this request actually is going to be used by the fuzzer, right? And first we need to specify the payload, position, because this is the fuzzer. So the fuzzer needs to know where the fuzzing should happen, in which place. But in the context of this case that I have here, I don't want to do a fuzzing over a specified parameter. I just wanna send this request many times, concurrently in a multi-threaded manner. So the payload's gonna be null, empty, right? But I have to tell this message, to the fuzzer so that it knows that the payload is null, empty. So I'm gonna go to payloads right now. I'm gonna click add, and I'm gonna choose empty null. And now number of repetitions. So how many times I want to send this, request actually to the web application. Let it be like 200, okay? Why not? So yeah, this is it. And I'm gonna click OK. So I am about to send this one particular request 200 times to the web application. And this request is about money transfer $10 from one account to another. So in the best case scenario from the attacker's point of view, I will be able to withdraw 200 times $10, right, from the account, so $2,000. This is the hypothetical, theoretical, the best case scenario, right? So if I'm able to, if I am actually making a money transfer $10 200 times, then if this exploit works, then at maximum I can, withdraw $2,000. But this is a theoretical maximum. You will see what it means actually later on in this video, okay? So I believe that this is clear for you. So far, we have configured the fuzzer to send one request 200 times without any modifications, just the same request. But as I told you a couple of times already in this video, multi-threading is the prerequisite for this attack. So now you need to go to options here, and there is something like concurrent scanning threads per scan. Here our multi-threading can be configured. So let's choose, for example, 20. Right now, the concurrent scanning threads per scan is 20. This is how I'm configuring multi-threaded attack in my fuzzer, okay? Which is really fundamental piece of this exploit here. Great. So right now, I've got everything. I've got multi-threading implemented. I'm about to send this request 200 times. So let me do it right now and let me click Start Fuzzer. You know, it's blazing fast. We've got multi-threading. We've got concurrency here. So it has been finished very quickly. Now let me release the interceptor here. Let me refresh my web application and let me show you what's the consequence of this attack, okay? What you can see here is that, well, I was able to transfer $1,090. It's really cool. I had only 1,000 and I was able to transfer more. I was able to transfer $1,090. So you can clearly see Michael, $0, James, $1,090. It's just, you know, amazing. It works. This is how you can actually use multi-threading to trigger race condition, and via race condition, how you can steal some money from a bank. So what I have presented so far to you is how this attack works and how to make it work, okay? And you see the power of this attack. But what I have to do more in this video is I just want to explain to you why it works, okay? So let me go right now to the whiteboard and let me provide some more explanation. I have the web application, which is here, and there are many incoming requests, many actually concurrent incoming requests to this web application. And these requests are about to transfer $10 from one account to another account. This is exactly what I presented to you in the demo. So this is my multi-threaded attack actually, right? And now I've got money transfer requests. And let's assume that, for example, 3 requests have already been accepted, okay? So I've got 3 money transfer requests that have already been accepted. And let me explain to you what it actually means. So when you've got money transfer requests, then the web application has to check whether you've got enough money to, you know, make this financial transaction. And if you've got enough money, then the money transfer requests are gonna be accepted. So these 3 guys, and they are waiting to be processed. Okay, so this is what I mean by saying money transfer requests that are accepted. Okay, but what's more we're gonna have in the story is we're gonna have the 4th request as well. Let it be the 4th request here. And this request here is where the financial transaction is actually being made. So what we've got is the requests that are accepted and that are waiting to be processed. And we've got one request here that has already been accepted, but this is actually where my financial transaction is being made. So this is a kind of distinction between this guy and these 3 guys here, okay? So far, so good. So what's gonna happen in my attack is that the balance sooner or later will go to 0. My attack is about sending $10 and $10 and so on many times, right? $10 from one account to another account. So sooner or later the balance indeed will be 0. Now let's assume that once this guy is processed, so once this financial transaction is being made, then the balance is updated and the balance is actually 0, okay? Let's assume something like this. So when the balance is 0 here, we've got some really interesting condition here, because the balance is right now 0. So it basically means that, well, I cannot send more money from my account because the balance is 0. But please notice that there are 3 money transfer requests that have already been accepted. So we've got a really strange situation. From one point of view, the balance is 0. So no more money should be, withdrawn or transferred from my account. But on the other hand, free money transfer requests have already been accepted, and these guys will be processed even further because they have been accepted before the balance went to zero. And these three guys here are actually responsible for stealing more money from a bank. This is actually how race condition works. Now let me tell you why we've got a race condition here. Well, indeed, we've got a race because the question is like this: how many threads are gonna be accepted, right? How many money transfer requests are gonna be accepted before the balance goes to zero? That's the question. And the more money transfer requests gonna be accepted before the balance goes to zero, the more money the attacker can steal from the bank, right? This is how it works. This is a race. Who's gonna be faster, right? And the number of money transfer requests that are gonna be accepted before the balance goes to zero, is dependent on many different things. That's why this attack is non-deterministic. What I mean here is that the network performance has an impact on this attack. The performance of the machine where the web application is hosted has also impact on this attack. Think about swapping, right? When we've got a swapping on the machine where your web application is hosted, it also has an impact on this attack. And this attack is about concurrency, multithreading, and fractions of milliseconds. So you see that this is indeed a race. This is how it works, and I believe that this is clear for you. But let me also tell you how to prevent it from happening, because this is also interesting. What we should do is we should never accept the next money transfer request before the money transaction request, the previous one, is being finished, okay? So first, what we should have is this guy should finish, then the balance should be updated, and once the balance is updated, then we should accept the new incoming money transfer request, right? And then we are guaranteed that race condition will not happen. So one thread at a time. When you are here making a transaction, then let's do it. Let's finish it. Then let's update the balance, then check the balance, and then allow or disallow the next thread, the next money transfer request, okay? So one thread at a time only in the system would prevent this attack from happening. So I believe that this is clear for you. And if you're gonna implement this countermeasure, then I recommend you to implement actually the transactions in the databases, because this is gonna solve your problems, okay? So I believe that this is clear for you. Let me right now go to the slides and let me wrap up what I presented here. So I used many concurrent requests to transfer $10 from one account to another account. And I presented to you that the race condition happens when money transfer requests are accepted faster than financial transactions are being made, right? This is what I actually tried to explain to you on the whiteboard. And when the balance goes to zero, there are still a few money transfer requests, already accepted ones, that are waiting to be processed. So this is how we can actually steal money from a bank via race condition. And finally, I presented to you, a kind of high-level overview of the countermeasure for this attack, because you definitely don't want this attack to have an impact on your own systems. So I also mentioned transactions and how to fix the problem that I discussed here. Okay, so I believe that you really like this case and you see the power of race condition exploitation. So we are right now done with this case. And in the next one, in the case number 2, I will dive even more into race condition exploitation, and we're gonna have even more fun with this kind of attack. So yeah, we are done with this case. So let's right now jump to the next one.